Alright, today's video we are going to put a couple different ideas together. We spent a lot of time going over different conic sections, and earlier in the semester we did a whole chapter on systems of equations, and we did 2 variable systems and we did 3 variable systems. Now we're going to put systems and conics together, and the first day that we're going to learn how to solve, we're going to learn how to solve by graphing. Now, if we are going to graph anything, we know that to go into our calculator, you always need to have everything solved for y equals. So we start with our first equation, x squared plus y squared minus 16x is equal to a negative 39. Note to yourself that if you cannot solve for y, then you can't solve by graphing. So we move the x squared and the 16x over. Y squared is equal to a negative x squared, a positive 16x minus 39. Again, we just move that x squared over to the right side. We move the x over to the right side. Now we almost have it solved for y. We have to square root, and we know that anytime that we are solving for something that's originally squared, we have a positive negative, which means to enter this into your calculator, you're going to have to put 2 different equations in, because your calculator does not have a plus or minus button in the graphing portion. So in y1, we'll have the square root of a negative x squared plus 16x minus 39. And then in y2, we'll have a negative square root of a negative x squared plus 16x minus 39. So for that one equation, we're going to have a y1 and we have to have a y2. Let's go over to our second equation. 5x squared plus 9y squared is equal to 161. Again, so we want to move the x's over, so we've got 9y squared is equal to a negative 5x squared plus 161. Divide everything by 9. Now we're not talking about lowest terms, and we're not having to worry about simplifying everything, so you can just leave it divided by 9. So y squared is equal to a negative 5x squared plus 161 over 9. And then again we have to square root. So y is equal to plus or minus the square root of a negative 5x squared plus 161 all over 9. And again, don't worry about simplifying this radical. You just want to make sure that everything's in the right spot. We're not going to break down radicals since we're using our calculator to graph it. So here, again, we're going to have 2 equations. So now we're down at y3. We're going to have a positive negative 5x squared plus 161 over 9. And then in y4, we'll have a negative square root of a negative 5x squared plus 161 all over 9. So we have 4 total equations that we're going to plug in. Before we turn to our calculator, let's go ahead and look at the equations. When I look at equation number 1, x squared plus y squared, since I have an x squared and a y squared, and they both don't have numbers with them, which means they have the same radius, I should expect to see a circle for the first equation. When I look at the second one, I've got x squareds and y squareds, but they have different numbers with them, which means they have different radii, which means this is going to be an ellipse because they are both being added. You should always know what to expect before you graph. If you don't know what you're looking for, you don't know if you maybe plugged a number in incorrect. If you forgot an x or a squared or something, you're just going to look to see what your calculator gave you. You have to know what to expect. So now I want you to go ahead and press pause and get your calculators out. Alright, let's look at our y1. We have the square root of a negative, make sure you use the negative, not the subtraction, x squared plus 16x minus 39. And remember, some of your new softwares, it'll all be the same square root. Don't worry about that. It might look slightly different. And the second one, we have to have a negative on the outside. So a negative square root of a negative x squared plus 16x minus 39. So that takes care of our first 2 equations. We move down, we have our y3. This one's going to be a little bit more difficult. Since we have a fraction underneath your radical, if you don't have the new software, like you see that I don't, you're going to have to make sure that you have an extra set of parentheses. We want to make sure that our numerator is grouped together in both y3 and y4. Some of you that had the new software, it automatically makes it into a fraction for you, so don't worry about that. So we've got the square root of we add a parenthesis, so if you have the old software, you should have two parentheses there. A negative 5x squared plus 161. Close out that parenthesis, showing that you've got the top of your fraction, good, divided by 9. So you have this set of parentheses to close out the numerator, and then you do a closed parenthesis that closes out the square root. The last parenthesis is not necessary. And the same thing in y4, except for we have a negative on the outside. We add that additional square root for the numerator of our fraction so that we make sure that the numerator is grouped together, and then divided by 9. We always want to start off in a standard window so we can kind of gauge what our graph is going to look like. So we go to zoom 6. It's going to graph in the order in which it was entered. So we saw y1, then y2, y3, and then y4. And I see that my graph is cut off just a little bit, so I'm going to change my window. I'm going to move my x's over. I'm just going to move it over to, let's see if 15 is enough. Okay. From here, we want to go ahead and sketch what our graph is going to look like. Okay, we know that we have a circle and we have a ellipse. We're going to get some points from our table. So second graph, we look at our table. So it's not going to exist. Our y1, our y2 doesn't exist there. But we see that for our y1 and y2, which is for our first graph, which is a circle, when x is 3, our y is 0. So I know I'm going to have a point right here. I look down some more. When I've got 4, I've got a value of 3. When I've got 4, I've got negative 3. And you don't have to plot a whole lot of these points. Let's find out when our other value is at 0, so we can kind of get a better idea of what our graph looks like. So at 13. So we're going to move our graph over just a little bit. And we're going to make some lines there. So that's 10, 11, 12, 13. So there's our rough looking circle. And then we've got to look at our ellipse. So we scroll over and we want to look at our values for our ellipse to get a general shape. And we look at our graph, we just know it's going to be around here. Kind of look at the graph 1, 2, 3, 4, 5, 6. So around 6, and it's going to go up to 1, 2, 3, 4, maybe a little over 4. So these are just going to be rough sketches. And it goes 1, 2, 3, 4, 5, maybe 5.5 left. And there's our sketch of our ellipse. Now what we have to do is find the intersection point between them to find where they match at. To do this, we go to second trace. We want to find our intersect, which is number 5. Now this is the hardest part. We want to be able to find the intersection between these two. Well, if I'm looking at my graph, this is y1 and this is actually y3, because this is y1, y2, y3, y4. So it's really important that you're paying attention to where the equations are located, because the first time you're going to have to jump around. Right now it's saying on y1. I want to get a point, so I'm going to arrow to the right until I get some points. So I can see, until I can see my cursor on this, I hit enter. It will automatically bounce down 2. I don't want that because I don't want the intersection between the top and the bottom of my circle. So to move on to the next one, I arrow down and you can see that it's changed to y3. And now you can see that I have my cursor on the top of the ellipse. I hit enter. It asked me to guess, so I go back towards, and we find that our first intersection point is at 4, 3. We want to find our other intersection point. When we look at the two graphs, they're only intersecting at 2 spots. So second trace again, intersect again, first curve. Well, I'm done with the top halves, so I arrow down. Now I'm on y2, enter. Second curve, it bounced all the way back up to the top. Remember, we don't want the top, so we arrow down, and that will give me my second curve, which is in y4, which is what we want. Enter. Guess, enter. And we find that the second intersection point there is at 4, -3. So you're going to have two solutions for this first graph. Your two solutions are 4, 3 and 4, -3. Two intersection points means two solutions. When you're going in between the different equations, the left and right will move you along that equation. The up, down will move you to a different y. So a y1, a y2, a y3. Okay, so the calculator work in this is pretty difficult. Let's move on to our next equation. What I want you to do is press pause, and I want you to solve both of these equations for y on your own. Okay, let's see how you did. So right now, you should be checking your equations. If you got them wrong, press pause and really go through and find out where you made your mistake. All we're doing is solving for y in each of them. Because we have y squareds, that means we're going to have plus or minuses, so we have two equations to enter for both. And again, let's look and expect to see what our graph should give us. So we've got a 3 and a 4, an x squared and a y squared. One's positive, one negative. So this tells me that this is going to be a hyperbola. So I should expect to see a hyperbola. An x squared, a y squared, a 3, a 4, they're different, they're both positive, so this should be an ellipse. Alright, so we go back to our calculators, our first one, and don't forget that we want to put parentheses around our numerators to make sure that when we enter them in, our numerators are indicated as numerators and not as one big long fraction. So you've got to make sure if you have the old software, you put your parentheses in. So go ahead and press pause, spend that time entering those equations, and then hit play to see if your graph is correct. Alright, as we are graphing those equations that we entered, remember there was 4 of them. If your graph does not look like this, I'm going to go back to my y equals, double check that all of your equations are correct. If I go down, there's the rest of my y4. So check the equations. Now what I do is sometimes I kind of cheat before I draw my graph. I look and I see that my hyperbola is over at 2. So I know over here that's my hyperbola. And over here that's my hyperbola. Just from looking at them, they're about 2 is those intersection points. The rest of them are really hard to see. They're really bad shape. I know that I'm going to have intersection points. When I look at my graph, I should expect to see 4 solutions. 1, 2, 3, 4. Because there's 4 intersection points. I'm actually going to cheat, kind of, and I'm going to find my intersection points before I finish drawing my graph. That way I have a better idea of the shape and it's a more accurate graph, unlike the first one we did. So we go to second trace. We want the intersection. Remember, it's going to start with y1. I'm going to arrow until I see my cursor. And down at the bottom, it will tell you your x-intercept. So it'll tell you whether you should be arrowing right or left. I want to find the intersection point between the top of my hyperbola and the top of my ellipse. So I hit enter. It will bounce down to y2. I don't want y2. I arrow down again, and it brings me to y3. And it gives me x, but that's undefined. So I want to move left so that it goes on my ellipse. Enter. Go back towards the intersection point. And I find that I have an intersection point at 3, 2. Now I want to find the other one. So again, second trace, intersect. I no longer want the top. I want the bottom of my hyperbola, and again, make sure that that cursor is blinking. Enter. It's undefined. It's on y3. I don't want y3, and if I arrowed left, I would see that that's the wrong one. So I arrowed down my y4, enter, scroll towards the intersection point, enter again, and that next intersection point there is at 3, -2. So I know I have another solution there. We've got 2 more to find. Second trace. Number 5, intersect. Now I want the top of my parabola and the top of my ellipse now, but I want the left half. So right now I'm at 2. My x on my hyperbola is way over here. So I got to keep going, keep going, keep going, keep going, and then it will bounce over to the other side. Hit enter. It goes down to the second curve. I don't want that. I want my ellipse, so I arrow down and see how it bounces to the top of my ellipse. Enter. Go towards your point. And our next intersection point is at -5, 4. So -5, +4. And then we do our very last one, second trace, number 5. We want the bottom of the ellipse this time, or hyperbola. Enter. It goes back to the top of the ellipse. I want the bottom of the ellipse, so go down. And again, the top left corner will tell you which equation you're on. Guess again. And now our last intersection point is a -5, -4. Remember, the arrow buttons left and right move you on the y that you're in. So the y1, y2, that moves you along the line. Going up and down will change you to the different equations from y1 to y2. So -5, -4. This will allow me, because I know that both my graphs go through it, to graph my hyperbola. There's the top, there's the bottom, my hyperbola over here, top, bottom, and then my ellipse, if I look, my ellipse is going 1, 2, 3, a little bit past 3. On this way, 1, 2, 3, 4, 5, 6, 7, 8. A little bit between 7 and 8. So about there. So I'm going to use those as markers to connect my ellipse. Again, knowing that it's going through all of those intersection points, and these are going to be my solutions because those are the points where my graphs intersect. 3, -2, 3, +2, -5, +4, and a -5, -4. So the hardest part about this is getting that ability to go into your calculator and make sure that you're able to manipulate the different equations. And we are finished.